Hello, in this video I'm going to talk about the steel deck. In this picture here, we have a profile of a steel deck, and there are different providers for the steel deck in the Canadian market. Some of them are Can-Am, and you have Vicwest, and we have Volcraft. The steel deck can be divided or classified into two classes. The first class is used as roofing material, which can be used for commercial plaza, and above that you can have your roofing material, which can be rigid insulation or gravel. And in this case we don't need to create any bond between the roofing material and the steel deck, and that's why you can see in this case you have a smooth shape, and this profile is used in the as roofing material. However, if we want to use the steel deck as composite floor, which can support the concrete, and there should be a bond between the concrete and the steel deck, and to create this bond the steel profile should be changed in such a case that there are more bond between the concrete and the steel deck. So the advantage of using the steel deck as a composite floor is big, or has a big advantage, especially when we have the in multi-story building, because it can eliminate the formwork, and normally the steel deck is used to support the concrete without any additional shoring, and the steel deck will be able to carry the weight of the wet concrete and also the construction crew. Now the profile of the steel deck can vary from 38 millimeter, 1.5 inches, to 2 inches and 3 inches, which is 76 millimeter. Now you can see the change in the profile, and also when we are using the steel deck as a composite floors, the amount of the steel bars which are used in the slab itself is much less than having a suspended slab. That's a big advantage too. So we have two advantages. One is eliminating or reducing the formwork. The second is reducing the steel bars inside the concrete slab. Now, what is the thickness of this material itself is here shown in this table. You have here the 22 gauge, and you have 20 gauge, and you have 18 gauge, and these units are used in the Canadian industry. However, in the Canadian code we are using the millimeter, and now the thickness in millimeter for 22 gauge is 0.76 millimeter, and for 18 gauge we have 1.21 millimeter. Now let's check if I have a span or spacing between the steel beams or open web steel joist about 2.5 meters, and I'm using 100 millimeter the concrete thickness, and the thickness of the metal sheet itself is 0.91 millimeter. In this case I have multiple spans, even more than 3, but I can use up to 3 spans, which gives me with 100 millimeter and 0.91 millimeter thickness, it can allow me to use the steel deck for a spacing of 2.17 meter as unshored. If, for example, I have 2.5 meter span between the steel beams, then I have to use shoring or supporting for the steel deck. In case that I increase the steel deck thickness from 0.91 to 1.21, and that gives me a spacing of 2.67 meter between the beams, which means that I have 2.5, which is less than the 2.67 meter, and that enables me to use the steel deck without any additional support, and this will be very effective to eliminate any support. So based on this catalog, you can decide if you need to have a shoring or not to support your steel deck. And after you know that your steel deck will need a support or not, you want during the installation process to support or to weld your steel deck above, or weld your steel deck to the supporting steel beams, and this welding point will be in the low point of the steel deck. If you look at the profile here, we have 36 inches wide, which is 914 millimeter, and you have 7 low point, and in each one of them you can have attack welding, which will give us a welding pattern of 36/7, or you can have welding in each second low point. You can have 1, 2, 3, and 4. That will give us 4 welding point over the width, or you can have even 9 welding point, and this welding point can be, I have 2 here at this end and 1 in each low point or valley, and another 2 at this end, so I can have up to 9 welding point. This number of welding point will affect the flexibility index of the steel deck, and that's used in the design of the effect of the diaphragm and the bracing resistance and the load distribution on the bracing for the lateral loads. So we have to make sure that we weld the steel deck to the supporting steel members, and we wanted to make sure also that the steel deck can carry the load without a shoring, or if we need a shoring we have to specify that, and we should have a discussion with the steel provider and also with the structural engineer. Thank you.